So on part D of this one, we're supposed to find the acceleration of the object as it passes this position, positive 0.6. And I think a lot of you thought that maybe you were supposed to use your answer to C somehow because you know that acceleration is the rate of change of velocity. So like we know that acceleration is dv by dt. But then the problem with that is that that's a derivative with respect to time, and we don't really have any information about time in the problem. And so I think a lot of you got kind of stuck at that point. But what you can do is, since we have potential energy as a function of position, you have to use the relationship between force and potential energy. So we have to use the fact that force is always the opposite of the position derivative of potential energy, is how we can get this. So then we just take our potential energy function and find the derivative of it with respect to x, just using the power rule. And when we do that, we get 8x. And then there is a negative sign there. So that means the force as a function of position is negative 8x. And then once we have a force equation, we can easily get the acceleration. So if we then find the force at the position they give us, the 0.6, we can plug that in as x. And then once we have that, we can find acceleration just using Newton's second law. So acceleration would be the force divided by the mass, and that would give us our acceleration. And we're not going to include a negative in our answer. The negative means that it would be to the left in this situation. But the question just asks for magnitude, so we're going to give our answer as positive, but we are going to give units with it.